This week we're talking about confirmation and falsification. Both of these concepts seem to be very important to science, and so philosophers have spent a lot of time thinking about confirmation. Some of the questions we wrestle with include the following. What is evidence? When does one hypothesis explain the evidence better than another hypothesis? How do we measure the extent to which some evidence supports a hypothesis, and so on? These are all questions that are discussed both in epistemology, philosophy of science, and in particular, confirmation theory. So in this presentation, I want to talk a little bit more about the concept of evidence and then ways of thinking about confirmation. So let's take up the first question. What is evidence? I'm going to present a probabilistic notion of evidence. There are other ways of thinking about evidence, but I think this is probably one of the best ways to think about it. And it's also a very popular way of thinking about evidence. It's important to note that this is a probabilistic notion of evidence. That is to say, it has to do with probabilities. On this view, evidence is anything that makes some claim more likely to be true. Or evidence is anything that makes some claim more reasonable to believe. It might be helpful to think of an example. So consider H and D. H and D represent propositions. What is a proposition? A proposition is a sentence that can be either true or false. In other words, a proposition is a sentence that has a truth value. For example, 2 plus 2 equals 4 is a proposition. It's either true or false. The sky is blue is a proposition. It's either true or false. But things like questions or commands aren't propositions because they can't be true or false. Suppose someone told you, go clean up your room, and you said false. That would be really peculiar. A command isn't the sort of thing that can be true or false. Or a question like, should I clean up my room? It might have an answer, yes or no, but it's not true or false. So propositions are sentences that can be either true or false. In the example here, H and D represent the following propositions. H stands for Jones ate the cookie in the jar, and E stands for Jones's fingerprints are on the lid of the jar. So imagine you had a cookie, the last cookie in the jar in the kitchen, and you were saving it for later. And then you go to get the cookie after dinner, and it's gone. So you think to yourself, well, someone took the cookie. Who did it? And you devise the following hypothesis. You think to yourself, Jones ate the cookie in the jar. But you need some evidence for this hypothesis. Why should you believe this hypothesis? Well, suppose you find Jones's fingerprints on the lid of the jar. This is evidence that Jones is the one who took the cookie. After all, that Jones's fingerprints are on the lid of the jar makes it more likely or more reasonable to believe that he's the one who took the cookie. Before you had this evidence, it might have been unlikely that Jones was the one who took the cookie, or maybe you just didn't know how likely it was that Jones took the cookie. But you find this bit of evidence, and now it's more reasonable to believe that he took the cookie. It doesn't prove that he took the cookie. You don't have certainty that he took the cookie, but it's just a little bit more reasonable to believe than it was before. So in virtue of all of this, E is evidence for H. Again, this is different than thinking of evidence as proof. Sometimes people speak loosely or casually and will talk about evidence as if it's proof, but that's not how we're using it here. Evidence doesn't have to prove or guarantee that some proposition or hypothesis is true. It can make it a little bit more likely. It can make it really likely. But that's not the same as proving it. So proof is a much stronger concept. Think of proof as what you get in logic or in mathematics. If you ever took a geometry class, you might have done proofs where you start with some premises and prove a certain equation. Or maybe you've taken a logic class and have had to do proofs, say proving validity or something like that. In all those cases, the conclusion was guaranteed. If you start with the premises, you get the conclusion, and you can be certain that that conclusion follows. But evidence doesn't have to do that. And so it's important to recognize the difference. Evidence can make a belief highly likely to be true. It can make a belief highly reasonable. It can make it a little bit more reasonable, a little bit more likely, but it doesn't have to prove. And so someone can say, I have evidence for a belief without meaning that they're certain that the belief is true. Certainty is hard to come by, especially in the sciences, especially when it comes to a lot of our empirical beliefs. And that's okay. Even if we can't be certain of a particular hypothesis, it may still be reasonable to believe that hypothesis. We can still have good reasons or evidence for thinking the hypothesis is true. At least many would argue. So here are some of the results of this notion of evidence. First, as we've already discussed, you can get evidence for a hypothesis without that evidence making the hypothesis more than likely to be true. So a hypothesis is more than likely to be true if it's like above 50%. So suppose you're 30% confident that some hypothesis is true, and then the evidence pushes you above 50%. You're at like 90% confidence. Well, in that case, you have reason to believe the hypothesis is more than likely to be true. But something can be evidence even if it doesn't do that. Perhaps you go from 10% confidence to 30% confidence. You haven't passed 50%. But nonetheless, the evidence you found increases your confidence in believing the hypothesis to be true. So evidence can have incremental value, even if it doesn't push the probability of a hypothesis above 50%. Second, some bit of evidence on its own may not make H reasonable to believe. Again, it may only be weak evidence for H, but an accumulation of additional evidences can make H highly reasonable. So the cumulative force may be greater than the force of any piece of evidence on its own. So even a string of really weak evidences that are individually weak can have a large cumulative effect. Think of the grain of rice analogy. A single grain of rice may not tip the scale, but if you keep mounting these individual grains of rice, eventually the scale will tip. The same is true of evidence, according to this notion of evidence. It may not be that the fingerprints alone make it reasonable to believe that Jones stole the cookie, but suppose you get some more evidence. You have a witness that testifies to Jones having stole the cookie. You have video footage, or you see footprints leading up to the cookie jar, and they're Jones's footprints, and so on. The point is that a whole bunch of little, even weak evidences, taken together, can make it really reasonable to believe that some hypothesis is true. Okay, now I want to talk about methods for confirmation. I'm going to move pretty quick, so bear with me. It's one thing to know the definition of evidence. It's another thing to determine when some empirical phenomenon counts as evidence. We need to know when a definition is satisfied. That's what a method is for. So that's why this presentation is about evidence and method. So some terminology. Confirmation. E is confirmation for H if and only if E supports or is evidence for H. So confirmation is another way of talking about evidence. If something is evidence for H, then that thing is confirmation for H. It confirms H. So here's an easy method for determining when something confirms H. Premise 1, if H, then E. Premise 2, E, conclusion, therefore H, probably. So think of the arrow as a prediction arrow. In logic, this is called the material implication, but you don't need to know that. Just think of it as saying that E is not as a consequence of H. We expect E if H is true. And then it turns out that we find E. E turns out to be the case. That's what premise 2 tells us. So H is probably true. Alternatively, the conclusion may simply be that E confirms H. So instead of H being probably true because of E, H is just confirmed somewhat because of E. So again, if H, then E, E, and the conclusion is E confirms H. I want to make a really important point about this method for confirmation. This is not a deductive argument. The premises do not guarantee the conclusion. This is a probabilistic method for confirmation. So let's think of some historical examples. One's from astronomy. Imagine you're Aristotle. You think that the Earth is stationary, and it's at the center of the universe, and the stars and the planets are embedded in these spheres that are rotating around the Earth. Well, if that hypothesis is true, what would you expect to observe? If H is true, that's the Aristotelian system. What do you expect? You expect to see the stars progressively moving across the sky. And in fact, that's what we find. If you were to speed up the motion of the stars, it would look like they're turning around us. So on this method for confirmation, the observation of the movement of the stars is confirmation for the Aristotelian hypothesis. Again, that doesn't mean that we've proved the Aristotelian hypothesis to be true. It just means we have a little bit more reason to believe that it's true. So just as there's a method for confirmation, there's a method for disconfirmation. Disconfirmation. What does that mean? E is disconfirmation for H if and only if E is evidence against H. So an easy method for disconfirmation goes as follows. Again, premise one, we have the prediction premise, you might call it. If H, then E, where E is some observation, some phenomenon, or something like that. But instead of finding that, we find that that's not the case, not E. So the little tilde is the negation sign. The conclusion is that not H. As an example, think of Galileo's observation of the moons of Jupiter. According to the Aristotelian system, planetary objects and stellar objects only orbit the Earth. The Earth has this sort of privileged position at the center, and everything is orbiting around it. So if that's true, what would we expect to find when we make observations of the planets and of the stars? We would expect to find them moving around the Earth, and only the Earth. So let H be Aristotle's hypothesis, and E is the consequence that we only observe planets and stars orbiting the Earth. Well, Galileo discovered, by using his telescope, that Jupiter has moons, and these moons appear to be orbiting around Jupiter. So that's disconfirmation for the Aristotelian system. Why? Because H predicts that E, and E turns out not to be the case. There are objects orbiting other things other than the Earth. So in this presentation, we've discussed evidence. Evidence, as we're going to be using in this class, is any bit of information or observation or event that makes some hypothesis more likely to be true or more reasonable to believe. And then we talked about methods for determining when something counts as evidence. I mean, think about it. Why do you consider certain things as evidence? Suppose you're thinking about Darwin's theory of evolution. Suppose I told you the color of my shirt is evidence for Darwin's theory. You would probably say, no, it's not. And why is that? Well, the methods we've discussed tell us why. The color of my shirt, it's green, is not a prediction of Darwin's theory. Darwin's theory doesn't predict that my shirt will be green. So my shirt is irrelevant to his theory. So if we want to know what sorts of things count as evidence for Darwin's theory, we have to ask ourselves, what does Darwin's theory predict we'll find? What are the observations we should expect if Darwin's theory is true? And if we go out and find those things, we're finding confirmation for his theory. So these methods are a helpful way of thinking about evidence. They're not perfect, but something like each of these methods has been used in the history of science to think about when a hypothesis has been confirmed. If you want more information about this, check out the class notes, and I'll talk to you later.